It started as a quiet irregularity, a name on a spreadsheet. Nothing dramatic, just a small deviation in trajectory that passed unnoticed by most. XR 271, one of thousands of near-Earth objects cataloged, tracked, logged, and quietly forgotten. It was about the size of a football stadium, composed mostly of dense nickel iron, and on its way through the mid-range orbital corridor that most scientists had labeled routine. But routine had a way of disguising its teeth. At 3:14 a.m. on a Tuesday, the Arizona ENO monitoring array recorded a sudden, sharp velocity shift in XR 271. Not enough to trigger alerts, but enough to raise a single internal query. Trajectory modified, please confirm. The system auto-sent the signal to other observatories in Chile, Australia, and Italy. By the time Earth spun far enough to give them line of sight, the asteroid was gone. Not out of range, not occluded by a planetary shadow, simply absent. Telescopes peered through open sky, scanning where the rock should have been. But there was nothing. No thermal signature, no reflected sunlight, no residual tail or debris. Just a missing entry in a dataset that had, up until that moment, followed the laws of orbital physics with the precision of a Swiss clock. Dr. Naomi Elgin wasn't assigned to XR 271. Her specialty was long-period comets, icy travelers that took centuries to return. But she saw the memo, and something about it felt wrong. Not the disappearance itself, but the silence that followed. No urgency, no media alerts, no revised trajectory projections from the European Space Agency. Just nothing. She began digging, slowly at first. Old observatory logs, ENO impact probability charts, minor object alert archives that had been pushed offline. In one such dataset, a pattern began to form. XR 271 wasn't the first. In 2004, an object designated FT 189 had similarly vanished. Projected to make a distant flyby, it disappeared from detection 17 hours early. In 2011, a slow-rotating asteroid marked JX 902 was tracked until it hit a specific orbital threshold. Then no further data. 6 others, all medium-sized, all non-fragmenting, all drifting through the same swath of space before cutting contact. She ran a map overlay, aligning the orbital paths. A corridor emerged, a narrow spatial funnel that curved along a deep gravitational trough near Earth's Lagrange point. A perfect approach zone. But this wasn't about approach. This was about observation. Each of those objects, before disappearing, had entered a field of view that included Earth. They had all, every one, been looking at us. Dr. Elgin pulled historical radar pings from the NASA Goldstone Deep Space Network. There were gaps, not just missing data, but overwritten files, entire hours scrubbed from the live tracking archives. She requested backups, delayed, then denied. When she tried to access old ground truth imagery from international partners, she found pixelated placeholders in place of clear frames. It wasn't just a blind spot. It was being kept blind. She didn't accuse. Not yet. She just kept looking. She reviewed radiation anomalies, micrometeorite densities, cosmic background fluctuations. In a 9-year-old report from a South African array, she found an offhand comment by a junior intern. Target object changed reflectivity properties mid-transit. She had to reread it twice. Asteroids don't change how they reflect light. Not like that. Not in real time. Not across multiple wavelengths. The implication was subtle but terrifying. Either the object altered composition, or something was controlling its exterior shell. She searched more deeply. That's when she found a correspondence log tagged, not for distribution, buried in a foreign data sharing agreement. The message was short, dry, but the meaning landed like cold iron. Continue blackout procedures for Corridor L5, Vega Incline. Do not engage prediction models. Public forecasts will be seeded with decoys. It was dated 4 months before XR 271 vanished. Dr. Elgin sat still for a long time. Outside, the observatory was quiet. The cooling fans hummed softly. The stars above wheeled in their endless path. But now she understood the silence. It wasn't absence. It was control. XR 271 had not simply been lost. It had been hidden, and someone somewhere was making sure no one would see where it went next. That night, she submitted a formal request to cross-reference minor asteroid drift records with classified military satellite positions. Her request was denied in 38 minutes. But 2 hours later, an anonymous folder appeared in her inbox. Inside, 7 files, 7 vanishing asteroids, 7 identical gravitational curves, and 1 prediction line, a curve that ended, not in the void, but on a silent collision course with Earth. The projection line sliced across her screen like a quiet blade. It didn't scream. It didn't blink red. It simply curved downward, intersecting Earth's orbital path with all the finality of a secret long kept. The label was just as understated. XR 271, Probability Line A, Class D Impact Event. There was no timestamp, no calculated window, just the line, and a silence that felt deliberate. Dr. Elgin stared at the model in the early morning glow of her lab. No colleagues, no chatter. The room smelled faintly of coffee and old wires. Her fingers hovered over the keyboard, unsure what to type. This wasn't theoretical anymore. It was trajectory. She opened the embedded metadata from the folder. What she found confirmed her unease. The file's origin was not NASA, not ESA, not any university or observatory. It had been generated by a defense contractor specializing in early threat detection, under a joint directive she'd never seen before. The designation read, Skyvault, Passive Anomaly Watch, Group 04. It wasn't a scientific initiative. It was surveillance. The asteroid, XR 271, had entered a classified zone monitored by a deep sky surveillance array designed not to warn the public, but to observe in silence. She reached out to a trusted colleague in Austria, a radar imaging specialist named Felix who owed her favors. She didn't give details, only asked him to run a sweep of the L5, Vega corridor, using archived long-wave radar data from a private array he'd helped calibrate. When the results came back, they didn't show the asteroid. They showed a shadow, not the kind cast by light, but by radio waves, a distortion in the way radar bounced, bent, like fabric over something dense. XR 271 wasn't visible, but it had passed through the space like a ship through fog, leaving a wake. And that wake changed direction. Objects on natural trajectories don't correct course mid-transit. Not with precision, not with acceleration, not without burning fuel or leaving trace signatures. But this wake had curved subtly, then sharply toward Earth. Just as the signal disappeared, Dr. Elgin reviewed the timestamps again, cross-referenced the Doppler shifts. The numbers made no sense. The asteroid wasn't drifting. It had maneuvered. That word stayed with her like a splinter. She pulled every published prediction model for medium-class impactors over the last 20 years. Most were public, crowd-shared through citizen astronomers and AI simulations. She ran comparison checks between official models and the data in the anonymous folder. The discrepancies were small, fractions of degrees, but every one of them nudged the paths closer to Earth. Over years, over generations, death by calibration. She looked again at the vanished objects from the previous decade. 7 asteroids, 7 disappearances, Each one had followed the same quiet curve, same corridor, same zone, but the curve didn't end at Earth. Not exactly. It ended just beyond it, in the vast cone of shadow Earth casts into space, the Umbra, a place where satellites go blind, where telescopes see only the absence of reflected light. That's where they were hiding, or worse, waiting. Her thoughts turned to the old impact stories. Tunguska, Chelyabinsk, craters in Siberia with no fragments, sudden explosions with no warning. What if they weren't random? What if those were tests? Or mistakes? What if we've been watched not through telescopes, but from behind them? She drafted a report, short, precise, titled Trajectory Drift and Anomalous Object Behavior in Vega Corridor. She marked it confidential and sent it to 3 trusted labs under secure encryption. 2 responded with agreement, quiet fear. The 3rd responded with a warning. Stop looking. That message came not from a scientist, but from a private email routed through a defense contractor's proxy server. No signature, no threat, just those 2 words. Dr. Elgin knew what that meant. She wasn't the first, and she wasn't supposed to be looking. She backed up her data, disconnected from her institutional network, started copying logs to an isolated drive. But even as she worked, she noticed something strange on her system clock. It had reset, not to midnight, to 3:14 a.m., the same timestamp when XR 271 first shifted. She stared at it, froze. Was it coincidence? Or was the asteroid's re-entry point already calculated, down to the minute? That night, her small rural observatory experienced a localized power surge. Nothing catastrophic, just enough to knock the mainframe offline. The next morning, when she restored the files, her trajectory folder was empty. No backup, no metadata, only one new file remained. A single frame image, a photograph of Earth from high orbit. Except the Earth was dark. No city lights, no clouds, no oceans, just shadow. And in that shadow, one small reflective dot. Unmoving, waiting. The breakthrough didn't come from a NASA lab or a European deep space telescope. It came from a converted shipping container in the Andes, where Argentina's Cerro Leon Observatory had been quietly tracking sky anomalies for years. Underfunded, undernoticed, but remarkably precise. A junior analyst named Eva Marquez, working the night shift with a thermos of mate and no expectations, noticed something odd. It wasn't the object itself. XR 271 had already slipped from official tracking. It was what remained in its wake. Gravitational pulses, minuscule, rhythmic, and far too regular to be natural. Every 9.17 minutes, a ripple emerged from the coordinates where XR 271 had last been observed. Not noise, not echoes, pulses, as if space itself had been tapped deliberately by something that knew the language of orbits. Eva triple-checked the data, assuming interference. But the pattern persisted over 3 nights, growing more precise, not less. Like a machine calibrating itself. When the pulses were translated into velocity markers and fed into orbital prediction software, the system responded with a single line of text: course stabilization complete. But no one had instructed the model to simulate a course. More alarming, when the full trajectory simulation was executed using this new pulse-guided data, the result wasn't a dispersal path. It was a correction arc. XR 271 wasn't drifting. It was adjusting. Its path had changed not away from Earth, but toward it, with refined precision, toward a corridor in the atmosphere known among mission planners as Corridor 3B. A statistically probable, thermally tolerable point of entry used in multiple satellite re-entries. But this asteroid wasn't a satellite. It had no heat shielding, no onboard propulsion, no reason to know where to go, unless it was being told. The simulation offered one more surprise: an estimated atmospheric contact timestamp. 14 days, 3 hours, 7 minutes from the current moment. The data had never been told to calculate impact. The model generated the timestamp unprompted. At the International Orbital Threat Conference convened in Vienna, the data stunned delegates into silence. Analysts from Russia, India, the US, and Brazil confirmed the telemetry. XR-271 had altered its orbit via external, non-ballistic force, a change consistent with targeted pathfinding. That term sent chills. Not drifting, not falling. Targeted. One observer compared it to an archer calculating not just the shot, but the precise wind drift, angle of descent, and atmospheric density at the exact time the arrow would land. Except this arrow was 320 meters wide and composed of heavy silicate metals that shouldn't possess maneuvering intelligence. The immediate fear: propulsion. But no heat signature, no ion trail, no debris jet suggested thrust. Only those quiet pulses. The Argentine team released full raw telemetry to open-source researchers. Within hours, a pattern emerged in the signal spacing, based not on astronomical time, but on Earth's own orbital wobble. A precession-aware timing structure. Whatever was guiding XR-271, it wasn't just aware of Earth. It was accounting for the planet's micro-oscillations, its subtle gravitational swell as it moved closer to perihelion. As if the object anticipated its target moving. Then came the oldest fear of all. Someone at ESA mentioned the Tunguska event, a mid-air explosion over Siberia from an object that left no crater but flattened trees for miles. Some had speculated it was an asteroid fragment, others a comet. But what if, just what if, that too had been a correction arc? A test? A failed entry? Speculation bloomed fast. Was XR-271 a probe? A weapon? Or something stranger? Within the Cerro Leon Observatory's server logs, EVA discovered something else. The gravitational pulses, each logged as harmless data points, began to shift slightly after the Earth station's predictive model was run. Almost like the object responded. The moment the Earth-side system identified the projected date, the pulses slowed. Not by much, just enough to recalculate the ETA by several seconds. It was no longer just a trajectory, it was a conversation. By the following morning, a second timestamp had been generated. Not from Earth, from the object itself. Carried in the frequency gap between pulses, a date, the same as Earth's simulation, but 4 seconds earlier. A challenge, or a warning, or an invitation. The United Nations Emergency Committee received the joint report at 6:47 Universal Time Coordinated. The final page contained a quote from Eva herself, scribbled into the log margins during the last signal check. It's not falling, it's deciding, and somewhere in the silent cold of the upper atmosphere, XR-271 waited, not to be observed, but to be understood. By the time the public noticed, it was too late to explain. The sky still looked the same. No fire, no streak, no object looming visibly overhead. But something had shifted beneath the surface. An atmospheric pressure you couldn't measure with instruments, but felt in your bones. Television anchors hesitated mid-sentence. Digital clocks paused for a blink too long. Commercial flights were rerouted with no announcements. And satellite news channels, once filled with minute-by-minute updates on XR-271, pivoted abruptly to weather reports and ceremonial events no one remembered scheduling. It wasn't a cover-up. It was silence curated at scale. And yet, those who listened beyond sight, those attuned to frequencies not made for ears, began to understand. The infrasound detectors were first. Buried deep across the world's seismic monitoring stations, they recorded harmonic tremors from space. Not tremors in the traditional sense, but elongated pulses that stretched like breath held in the chest of the cosmos. Rhythms not unlike music, but too deliberate to be natural. They came in intervals, 2 beats, then 3, then 5, then 7, prime numbers, not warnings, markers, not information, structure. The intervals matched no known pulsar, no known communication signal, no Earth-based tech. And yet, the timing aligned with a singular orbital curve, XR 271's projected descent window. A countdown, measured not in seconds, but in intention, inside the abandoned data hub in Patagonia, where the Cerro Leon Observatory had rerouted its remaining feeds. Eva sat alone. Her colleagues had been reassigned. The official servers had been shuttered, but she'd built a private backup, an off-grid system designed to listen when the world refused to hear. The infrasound waveforms appeared first as symmetrical loops, then spirals, then, impossibly, a frequency pattern that resembled the cochlear structure of the human inner ear. The asteroid wasn't just sending a signal, it was echoing one. Something we had emitted long ago, maybe radio, maybe thought, maybe heartbeat, and it had shaped itself accordingly. Not to mimic, to understand. The last automated update from the orbital array arrived just past midnight. It wasn't data, it wasn't coordinates. It was an image, one still frame, no metadata, no timestamp, just a black background punctuated by starlight, and the object, no longer a rugged sphere of silicate and nickel, no longer tumbling. Now, it drifted with orientation. Now, it faced the camera, and its silhouette had changed. It was not a mouth, not a weapon, not a symbol. It was an ear, sloped, curved, asymmetrical in a way that felt disturbingly biological. The top folded like cartilage, the canal a hollow shadow, a listening shape, not built but evolved, sculpted not by pressure or explosion or gravity, but by comprehension. Eva stared at the image for hours. The pulses slowed, the countdown neared 0, and still, the object did not speak. It only listened. Around the globe, the last updates flickered in private server farms and forgotten backup archives. Places no algorithm would prioritize, no broadcaster would search. And in those quiet places, the truth settled. This was never a message to us. It was a message from us. Reflected, returned, answered, as Eva shut down her system and walked into the pre-dawn air. The sky remained unchanged. But above, in silence so complete it seemed sacred, something waited. Not to land, not to warn, but to hear. And whatever it heard in us, it came closer,